Welcome to Summarize Science. Have you ever wondered if the moon is hiding secrets from across the galaxy? The lunar surface, or regolith, acts like a dusty archive, capturing evidence of solar winds and even distant stellar explosions. However, constant meteorite impacts act like a giant cosmic blender, a process researchers call lunar gardening. This mixing makes it difficult to figure out exactly when and how much material arrived from outside our solar system. To solve this, researchers developed a new mathematical model that treats this mixing as a combination of moving and spreading, much like ink in water. They call this an advection-diffusion model, which tracks how the soil is stirred over time. They focused on a specific isotope of iron 60, which is a clear indicator of supernova activity. This version of iron usually comes from massive stars that ended their lives in spectacular explosions millions of light years away. By looking at samples brought back by the Apollo missions, the researchers tested their model against real-world data. They found that the model accurately predicts how deep this supernova dust gets buried over hundreds of millions of years. Interestingly, the model suggests that the capture of this cosmic dust is independent of how much iron is already in the lunar soil. This uniformity makes the moon a more reliable witness than researchers previously thought. The study also explores even rarer elements like plutonium-244, which might originate from exotic events like neutron star mergers. By analyzing these deeper profiles, they can distinguish between single pulses of dust and a long-term steady rain from space. Their work suggests that distinct pulses of iron 60 hit the Earth and Moon about 2 million and 7 million years ago. These results give a much clearer picture of the recent history of our solar system in the interstellar medium. This research provides a direct roadmap for future astronauts on the upcoming Artemis missions. By knowing how the soil is mixed, they can identify the best spots to find pristine samples of ancient cosmic debris. This could allow scientists to map out the history of the solar system's journey through the Milky Way galaxy. It also helps in understanding how the moon's surface changes over billions of years of bombardment. To recap the most important points, the moon is a messy but extremely valuable record of the universe's most violent events. While meteorite impacts scramble the top layers of the soil, sophisticated mathematical tools allow researchers to look through the noise. They have confirmed that nearby supernovae have indeed left their radioactive dust on our lunar neighbor. This means that lunar soil is not just dead rock, but a treasure map of stellar history. In the future, digging down about 100 centimeters could reveal the exact timeline of explosions that shaped our local space. This work bridges the gap between planetary science and deep space astronomy. It turns the moon into a giant telescope that looks backward in time at our galactic neighborhood. Every core sample retrieved by future missions will be like reading a new page of that history. Thank you for watching Summarize Science, where complex studies are made easy to understand.